Determine the limit by interpreting it as the definition of the derivative. Limit as h goes to 0 of 1 over the square root of 2 times 2 plus h minus 3 minus 1 all over h. This limit is of the form limit as h goes to 0 of f of a plus h minus f of a all over h, which is the definition of the derivative and is therefore equal to f prime of a. So instead of working out the limit directly, we can, as an alternative, find the derivative of f of x, f prime of x, and then evaluate it at a, f prime of a. In order to do that, we have to first determine f of x. And f of x is determined by comparing the f of a plus h to the f of a plus h term over here. And what we want to do is replace the a plus h with an x to give us back f of x. So if I take this a plus h out here and replace it with x, that will be f of x. This minus 1 here, this is actually f of a. We don't include that. So it looks like our f of x is 1 over the square root of 2 times x minus 3. 1 over the square root of 2x minus 3. The only other thing that we need is the a value. And the a value is found by comparing the a plus h to the a plus h over here. Whatever's added to h is the a value. And so the a value is a 2. We can then find the derivative of f of x and evaluate it at a. Before I find the derivative, I'm going to rewrite f of x because I do have a square root, and we will want to write that as a fractional exponent. It's first power, second root, 1/2 power. Since I have a constant in the numerator here, I'm going to want to rewrite this. No need for a quotient rule. I can bring the 2x minus 3 to the numerator as a negative 1/2 exponent and just use a power rule for the derivative. So the derivative, f prime of x, will be bring down the power, negative 1/2, leave the inside alone, 2x minus 3, subtract 1 from the power, I will call that 2/2, multiply by the derivative of the inside to complete the chain rule, a 2. Now I can bring this 2 out and multiply with this 1/2. 1/2 times 2 is 2/2, or just 1. So I have negative 1 left over. And I have 2x minus 3 to the minus 1 minus 2 minus 3 halves power. I can move that back to the denominator, leaving the negative with a 1 in the numerator. And we will have a 2x minus 3 in the denominator. It will now be to a positive 3 halves power. We want to evaluate that at the a value of 2, f prime of 2, which is going to be negative 1 over 2 times 2 minus 3, all raised to the 3 halves power. So you have negative 1 over 2 times 2 is a 4 minus 3 to the 3 halves power. So negative 1 over 4 minus 3 is a 1 to the 3 halves power. Now 3 halves power means to take the square root. The square root of 1 is a 1, and then cube the result, and 1 cubed is 1. So I have a negative 1 over a 1, which is equal to negative 1. And therefore, this overall limit up here is equal to negative 1.